5. The Crustal-Shifting stage, the Fern-Forest Carboniferous period, the Age of Frogs. The appearance of fish during the preceding period marks the apex of marine life evolution. From this point onward, the evolution of land life becomes increasingly important, and this period opens with a stage almost ideally set for the appearance of the first land animals. 220 million years ago, many of the continental land areas, including most of North America, were above water. The land was overrun by luxurious vegetation. This was indeed the age of ferns. Carbon dioxide was still present in the atmosphere, but in lessening degree. Shortly thereafter, the central portion of North America was inundated, creating two great inland seas. Both the Atlantic and Pacific coastal highlands were situated just beyond the present shorelines. These two seas presently united, commingling their different forms of life, and the union of these marine fauna marked the beginning of the rapid and worldwide decline in marine life and the opening of the subsequent land life period. 210 million years ago, the warm-water Arctic seas covered most of North America and Europe. The South Polar waters inundated South America and Australia, while both Africa and Asia were highly elevated. When the seas were at their height, a new evolutionary development suddenly occurred. Abruptly, the first of the land animals appeared. There were numerous species of these animals that were able to live on land or in water. These air-breathing amphibians developed from the arthropods, whose swim bladders had evolved into lungs. From the briny waters of the seas there crawled out upon the land snails, scorpions, and frogs. Today, frogs still lay their eggs in water, and their young first exist as little fishes, tadpoles. This period could well be known as the Age of Frogs. Very soon thereafter, the first insects appeared, and, together with spiders, scorpions, cockroaches, crickets, and locusts, soon overspread the continents of the world. Dragonflies measured 30 inches across. 1,000 species of cockroaches developed, and some grew to be 4 inches long. Two groups of echinoderms became especially well developed, and they are, in reality, the guide fossils of this epoch. The large shell-feeding sharks were also highly evolved, and for more than 5 million years they dominated the oceans. The climate was still mild and equable. The marine life was little changed. Freshwater fish were developing, and the trilobites were nearing extinction. Corals were scarce, and much of the limestone was being made by the crinoids. The finer building limestones were laid down during this epoch. The waters of many of the inland seas were so heavily charged with lime and other minerals as greatly to interfere with the progress and development of many marine species. Eventually, the seas cleared up as the result of an extensive stone deposit, in some places containing zinc and lead. The deposits of this early Carboniferous age are from 500 to 2,000 feet thick, consisting of sandstone, shale, and limestone. The oldest strata yield the fossils of both land and marine animals and plants, along with much gravel and basin sediments. Little workable coal is found in these older strata. These depositions throughout Europe are very similar to those laid down over North America. Toward the close of this epoch, the land of North America began to rise. There was a short interruption, and the sea returned to cover about half of its previous beds. This was a short inundation, and most of the land was soon well above water. South America was still connected with Europe by way of Africa. This epoch witnessed the beginning of the Vosges, Black Forest, and Ural Mountains. Stumps of other and older mountains are to be found all over Great Britain and Europe. 200 million years ago, the really active stages of the Carboniferous period began. For 20 million years prior to this time, the earlier coal deposits were being laid down, but now the more extensive coal formation activities were in process. The length of the actual coal deposition epoch was a little over 25 million years. The land was periodically going up and down due to the shifting sea level occasioned by activities on the ocean bottoms. This crustal uneasiness, the settling and rising of the land, in connection with the prolific vegetation of the coastal swamps, contributed to the production of extensive coal deposits, which have caused this period to be known as the Carboniferous, and the climate was still mild the world over. The coal layers alternate with shale, stone, and conglomerate. These coal beds over central and eastern United States vary in thickness from 40 to 50 feet, but many of these deposits were washed away during subsequent land elevations. In some parts of North America and Europe, the coal-bearing strata are 18,000 feet in thickness. The presence of roots of trees as they grew in the clay underlying the present coal beds demonstrates that coal was formed exactly where it is now found. Coal is the water-preserved and pressure-modified remains of the rank vegetation growing in the bogs and on the swamp shores of this faraway age. Coal layers often hold both gas and oil. Peat beds, the remains of past vegetable growth, could be converted into a type of coal if subjected to proper pressure and heat. Anthracite has been subjected to more pressure and heat than other coal. In North America, the layers of coal in the various beds, which indicate the number of times the land fell and rose, vary from 10 in Illinois, 20 in Pennsylvania, 35 in Alabama, to 75 in Canada. Both fresh and saltwater fossils are found in the coal beds. Throughout this epoch, the mountains of North and South America were active, both the Andes and the southern ancestral Rocky Mountains rising. The great Atlantic and Pacific high coastal regions began to sink, eventually becoming so eroded and submerged that the coastlines of both oceans withdrew to approximately their present positions. The deposits of this inundation average about 1,000 feet in thickness. 190 million years ago witnessed a westward extension of the North American Carboniferous Sea over the present Rocky Mountain region, with an outlet to the Pacific Ocean through northern California. Coal continued to be laid down throughout the Americas and Europe, layer upon layer, as the coastlands rose and fell during these ages of seashore oscillations. 180 million years ago brought the close of the Carboniferous period, during which coal had been formed all over the world, in Europe, India, China, North Africa, and the Americas. At the close of the coal formation period, North America east of the Mississippi Valley rose, and most of this section has ever since remained above the sea. This land elevation period marks the beginning of the modern mountains of North America, both in the Appalachian regions and in the west. Volcanoes were active in Alaska and California, and in the mountain-forming regions of Europe and Asia. Eastern America and Western Europe were connected by the continent of Greenland. Land elevation began to modify the marine climate of the preceding ages, and to substitute therefore the beginnings of the less mild and more variable continental climate. The plants of these times were spore-bearing, and the wind was able to spread them far and wide. The trunks of the Carboniferous trees were commonly 7 feet in diameter, and often 125 feet high. The modern ferns are truly relics of these bygone ages. In general, these were the epochs of development for freshwater organisms. Little change occurred in the previous marine life. But the important characteristic of this period was the sudden appearance of the frogs and their many cousins. The life features of this coal age were ferns and frogs.